Alright, so moving into section 7.4, we got a really popular rule for derivative today that I'm glad you're watching this video because this is something you got to be able to do. So today we're looking at something called the chain rule for derivatives, and that goes with a problem like this where you're dealing with exponents. And so this is where the chain rule comes into play. So if you take a look at this example, if you go back to the old method, there is another way to do this. You could do 3x plus 1 times 3x plus 1 and get this look here, and then apply the power rule to each term individually and get this derivative. But you're going to find, especially within the problems within this video, that's just not a realistic process when you're doing this to some of the more complicated problems, and so you need to be able to understand the chain rule to do this. So here's another way to do this. So the chain rule does something like this. You take the derivative of the entire function and you multiply it times the derivative of the interior function, which looks like this. There is something for this in your formula packet, but unfortunately it's just not that clear of a process. So people see all these different letters floating around. There's a whole lot of D's with Y's and X's and U's, and students have a hard time applying this look to what you're supposed to do for this problem. So I'm going to try to give you a little simpler thought process than what you're seeing right here. But if this does work for you, then awesome. Notice on this one that u is the interior function. So what they did on this process, and here's kind of the long drawn out explanation of it. I'm going to give you the more realistic look right here. But if u is the interior function, then I am starting by finding the derivative of the entire function and then multiplying it times the derivative of the interior function. And that's really what this is trying to tell you, though it always seems a little unclear to people when they look at this process. So here's the approach that we would take. Let me go down to this look here. This is the realistic approach that you're going to do for any given problem. So if you see right here you have a quantity squared. So to apply the chain rule, we're going to start by taking the derivative of the entire function. So using the power rule, we would say, okay, well, let's take our exponent, multiply it to the front, so I'm going to put a 2 right there, and then I subtract 1 from my exponent, and this becomes a first power. And so that's what you're seeing initially. So this is the derivative of the entire function. So we got the 2 out front. This became an exponent of 1. But here's the extra key step that students just forget to do this all year long, and so I'm glad you're watching the video. But the last part of this is to multiply by the derivative of the interior function. And so 3x plus 1 is the interior function, so I got to multiply by the derivative of this, which would just be 3. So you got to throw that in. Now I can put the 3 with the 2 and get this look here. And so this is one way of seeing that derivative. If you distribute the 6, you get the 18x plus 6, which is what we got back up here. And so but this is just the way you would do it with the chain rule. So the key on this is going to be taking the second step of multiplying by the derivative of the interior function right here. So just to go through a few examples, and again, you should pause this at some point and give 1 or 2 of these a try. But again, I'm going to start by doing the derivative of the outer function or the entire function. So I'm going to take that 9 and multiply it to the front, and then subtract 1 from the exponent. So here's the 9 out front. My power drops down to an 8, but here's the key step that needs to follow, is you then have to multiply by the derivative of the interior function. So the derivative of this would just be 7, so I got to include that guy. So now I can put the 7 with the 9 and get my 63. Same thing on this, multiplying the 4 out to the negative 4 out to the front. So here's your negative 4. You subtract 1 from the exponent, so it becomes negative 5. And then here we are multiplying by the derivative of the interior function. And if you now put the 9 with the negative 4, you can get this look right here. Here we go, applying some of the newer rules. So you got e's and natural logs. Again, I'm going to start by doing the derivative of the entire function that you see right here. So remember that the derivative of e to whatever is just that item. So the derivative of e to the x to the 4th power is just e to the x to the 4th power. So this is the derivative of the entire function or the outer function. and now I need to multiply times the derivative of the interior function, which was this guy. So the derivative of x to the fourth, if we use our power rule, is 4x to the third. And now I can combine my 4 and my 5 to get this look that you see right here. And so this is your key step of multiplying by the derivative of the interior function, and that's what most students will not do on a test and get this wrong. So again, one more look here, you can see that I have something within a function. So this is no longer just the natural log of x, this is the natural log of something that's a little more complicated. So this is going to be our interior function. So again, if I start with the derivative of the outer function, or the entire function, well, we know that the derivative of the natural log of something is just 1 over that something. So if I did 1 over 5x squared, I'm going to get this look here. Here's the key second step that you got to take, is you got to multiply by the derivative of the interior function. So if I go back to here, this is my interior function. Derivative of this, if I do 2 times 5 and then subtract 1 from my exponent, I'm going to get 10x to the first. So here we are multiplying by the derivative of the interior function. And now if I just clean up as much as I can get it all the way to just 8 over x. All right, bottom part down here for part B. Now we're kind of combining rules here. So two things at work. I have a product rule because I have an x times an x. Right? I got two terms being multiplied together that both have x's in them. I also have a chain rule. So a really popular test question here. This is one you should be familiar with because they love to combine rules and all those things put together within one problem. So here's one you should definitely be familiar with. So generally speaking, if I'm going to find the derivative of the outer function or the entire function, I got to use the product rule. So here, let's kind of walk through the product rule. So if I took my first term, which is e to the x, times the derivative of the second. So right here at this stage, you're seeing the derivative of the second term. That's all this, which is the chain rule. So I'm multiplying the 4 to the front. I am subtracting 1 from the exponent. So that should bring this down to a 3. That should be a 3 right there. Times the derivative of the interior function. So the derivative of this interior function would just be 2. So that's where this 2 came from. It's the derivative of the interior. Plus, I have to do the second term times the derivative of the first. But the derivative of e to the x is just e to the x. So this is the entire layout that you need to come up with use of the product rule and the chain rule. And so that's all of that, and now you just need to do as much cleanup as possible. So a little combining like terms would get you this stage right here. If you factor out what they have in common, all right, this entire term was factored out of both terms, and so that's how we can come out to all the way down to this last step. This one is similar idea, but instead of product rule, now we're using the quotient rule. So for this one, we're going to use the quotient rule, but because this is not just the natural log of x, we have more going on here that creates that interior function that we have to include with the chain rule. So for this, if you start with your quotient rule, which is the bottom term times the derivative of the top minus the top term times the derivative of the bottom over the bottom squared. So the one key step within this was the use of the chain rule right here. So when we did the bottom terms times the derivative of the top, well, what's the derivative of the top? Right? We know that the natural log of whatever is just 1 over that term. So that's where you get the 1 over 6x. And then I have to multiply it by the derivative of the interior function. So the derivative of 6x is just 6. And so this piece right here is what you're seeing for the derivative of the top term. And then right here again, now you have minus the top over the derivative of the bottom over the bottom squared. And again, you know, simplify as much as possible. If you got it all the way down to this stage here, typically this would be okay. The one exception on this problem is that 4 can be divided into every term. So that's where you should take the one extra step of dividing out the 4 and getting this look right here. For the last example, this is one is asking us to not only find a derivative, but to plug a 2 into the derivative to get a value. So here we go with the chain rule for one last time. Again, let's put this in a friendlier format. So instead of a square root, we're going to write that as a 1/2 power so that we can use the chain rule. But again, here we go with the chain rule. So you're going to take the 1/2 and multiply it to the front, and then subtract 1 from your exponent. And so that's what you're seeing right here. You got the 1/2 in front. If I subtract 1 from the exponent, I get negative 1/2. Here's your key second step, and I'm glad you're still watching the video. This is important. So you got to multiply by the derivative of the interior function. So the derivative of this interior function would be 4x to the third, and so that's where this guy comes into play. And if you do a little cleanup on that, you can rewrite it to look like this. But now I need to take my one extra step and sub in a 2 for x because of this. So if I do replace my x's with 2's, that gives you this look right here, and we can clean that all the way up down to a single value. But that's how that would finish off.